Uniform acceleration is what I want to talk about now. That's simply when you have unchanging constant acceleration. So we are gaining the same number of meters per second every second, gaining the same amount of velocity every second. And a good example of uniform acceleration is gravity. The acceleration due to gravity is 9.8 meters per second squared. That's a number that after you get out of physics, you probably won't be able to get out of your head because we use it so much. But what that means is that an object falling towards Earth does not fall at the same speed, which you may have thought that before. But actually, I think you know that because if you answer the question, if I dropped a golf ball on your head, would you rather me do that from a height of 2 feet or from the height of the Empire State Building? Well, I think everybody would obviously choose the 2 feet because they would reason that it would hurt less because it would not be going as fast. Which tells me that most people know that the farther things fall, the faster they go, which means that they know things accelerate as they fall. And actually they accelerate at a rate of 9.8 meters per second squared. That means every second, in the absence of air resistance, every second an object gains 9.8 meters per second of speed. So if we drop an object and its initial velocity is 0, at the end of 1 second, its velocity is 9.8. And at the end of 2 seconds, its velocity would be 9.8 times 2, which would be 19.6, so on and so forth. And we'll talk about gravity in more detail at a later point. We need to talk about direction with acceleration, and consider that what I told you a long time ago, or not a long time ago, in the first video with acceleration, you need to calculate acceleration by calculating the final velocity minus the initial velocity. It's very important that you keep those straight, because if you switch them around, that can change the positive or negative. It's not going to change the number any, but the positive and negative will change, and that's key for acceleration because the direction of acceleration is important. Positive acceleration can mean a couple of things. It can mean speeding up in a positive direction, or it can mean slowing down in a negative direction. It can mean slowing down in a positive direction, or it can mean speeding up in a negative direction. I know that may not make sense to you, but the point is this: before this class, if I had asked you what is positive acceleration, most of you might have said it's speeding up. And if I asked you before this class what is negative acceleration, most of you might have said slowing down. Those are not always the case because it always depends on what direction the object is moving. Let's look at this table. So if an object is moving to the right, it's moving in a positive direction, and it's speeding up. I want you to think about acceleration as if it's a rope attached to a car. Okay, and if this car is moving in a positive direction, I want you to think about what direction the rope needs to pull in order to make the car speed up. Does it need to pull to the right in a positive direction? Or does it need to pull to the left in a negative direction? Well, clearly, I think it's obvious that the rope needs to pull in the same direction the car is moving in order to make it speed up. Therefore, that rope is what we're going to symbolize as the direction of our acceleration. So if the rope is going to pull in a positive direction, then the direction of our acceleration is positive. But if we're moving to the right and we're slowing down, if a car is moving to the right and a rope is going to slow it down, that rope must pull not to the right but back to the left. And that will be the direction of the acceleration. To the left is a negative acceleration. And now think about a car that's moving from right to left, moving toward the left, and it's speeding up. It's gaining speed because this rope is pulling it. And if that's going to happen, the rope must be pulling it from the left. In other words, the rope must be pulling to the left. It must be pulling in the same direction the car is moving. If the rope is pulling to the left, that's a negative direction, negative acceleration. And this might be blowing your mind right now because, again, up till now you've thought negative acceleration means slowing down. But in this case, because we're moving to the left, negative acceleration causes us to speed up. And lastly, if we're moving again to the left and we want to slow down, move the car to the left, but in order to slow down, the rope must pull not to the left, but to the right. Must pull back to the right, which is a positive direction, and therefore our acceleration is positive. So again, Positive acceleration you might have previously thought to mean speeding up. But if you're moving to the left, positive acceleration makes you slow down. Okay, so positive and negative acceleration will make your object speed up or slow down depending on whether the object is moving to the left or to the right. This is the guess method. I'm not going to go over it. It's in your notes. You can read it here. This is the method you need to use to solve all problems, and you need to use it to solve this problem. So I want you to solve this problem. If you want to, you can click on this link. This is a video describing what this man did in this problem, but in just a minute I will actually work this problem for you.